Why is the Wiimote generating such an interest? Computer input devices have been wide apart from natural human movement most of the time. Bridging this gap is a challenge. Nintendo did not invent gyro sensors, but they did manage to introduce their game controller into the mainstream, yielding its powers to programmers and researchers and opening up the video game world for people who don't normally play. The Wii Remote has 6 acceleration sensors, 3 for linear movement and 3 for rotational movement. It can also detect position through an infrared camera, which triangulates on a number of infrared light sources, usually supplied by a sensor bar. The acceleration sensors turned out to be too imprecise for gesture recognition. They introduce a lot of noise. The IR positioning is more accurate and better suited for fine movement detection. The Nintendo console also uses it for tasks like pointing. Gestures are interesting from a human-computer interaction point of view. This is due to the realization that most likely our current modes of interaction are far from optimal. Gestures are often seen as the future of HCI, although their current uses are limited. The Wii Remote seems perfectly suited for gesture-based interaction, because its main feature is detection of movement. In order to capture gestures, we define 8 directions in 2-dimensional space. For every move, we check the direction and record it. When the gesture is over, the resulting string is compared against the database, mapping gestures to program actions. When comparing, we calculate the Levenstein distance between the current gesture and each gesture in our library. This gives us a measure of how similar the string representations are. If there is a string with low enough distance, we trigger an action.
Now I will explain some more to you about what we do after we have categorized the movements. When doing a gesture, like down left for example, we of course want to store this in the database as 2-0, since we first go down, which is number 2, and after we go to the left, which is associated with 0. But the output, after we have categorized it, can look totally different. Here's an example of how it may look like. You see some 2's at the beginning, after it, some 1's and some 0's, and all these groups are also interrupted with other numbers. Since the movement is registered every 120 milliseconds, even when doing a small gesture like this, will give us a large string with many perturbations inside it also. We want to somehow interpret this as 2-0, since we stored it like this in the database. Here's how we'll do that. First, we'll prune out all the numbers which will occur just once, since they are most likely of no influence comparing to the ones that do occur more than once. Now we are going to group all the neighboring numbers which are equal to each other. So this will give us 3 groups like this. The last method of sorting will be done by size. As you can see, the first and the third group are much bigger than the second group, since the first and the third group are not completely shown here in this string. And every group which is smaller than 10% of the total string length will not be considered. So the thing which remains is a string of 2, 0.
Another aspect of FriiMotion was to explore the interactive capabilities of scalable vector graphics. SVG is a W3C standard for describing graphics in XML. It provides all the power of XML, structured content, walkable and editable document object model. It has some advantages over Flash. The format is open, text inside the document can be searched, and it is better integrated into other web technologies. The results of using SVG are good, although a lot of APIs do not provide complete support yet.